Hello and welcome to the second lecture in this series on an introduction to Java, particularly with an emphasis on understanding object-oriented programming. In the last video, we set up this framework for a little Hello World program, and we learned how to basically make the computer print something out to us, like so, with the following print line command, and we could have it say, hello world. And when we run that, whoops, I forgot my end quotation. And when we run that, we get hello world printed out in what is called our console down here. And so this is where we get all these displays. And so this is what we understand how to do so far. And we can, keep doing this, and you could have it say a whole bunch of, different stuff. Like so. It doesn't matter what you tell it. And when you run that, it'll print those lines straight back to you below. But this has very, obviously limited capabilities, and so we want to be able to expand our own worlds and be able to have some more capabilities and eventually be able to do things like manipulate numbers, because in the end what computers really are giant number crunching machines, and so the closer we can get to the numbers, the closer you can get to really unleashing the power of what computers can do at a fundamental level. So without further ado, I want to talk about variables a little bit. So in math, it is a very common thing to say something like x equals 5. And you then know that anytime you see an x, that's equivalent to 5. We have a very similar thing in Java among pretty much all programming languages. And I'm going to show you guys how to declare variables and use them. So what's a little different about Java than maybe like you would just say x equals 5 casually in math is that every variable type in Java has a type, what is called a type, and so that means that it needs to know what it is. We implicitly understand that, x is a number. In this case, x is an integer. If I make it 5.9, then you might say that, x is a decimal. But when you program, you need to very explicitly tell the computer what kind of variable it is. That way, it can store things appropriately and set aside the right number of bits in the memory so that it knows exactly how to store it and how to treat it in the future. And so what we have to add here, if we want x to be 5, we have to declare the type here, and the type for an integer is called an int, int. So if you just go ahead and type int here and then put a space, you'll see that it turns purple, which means that it is a Java keyword, like all of these class and public static void nonsense up here right now. And so that means that it's something that's built into Java, and it is a data type that Java knows how to recognize. So if you say, hey, I'm going to make an int, Java says, okay, I know what that is. I know how to deal with these. You can go along on your merry way and make that int. And we're assigning it this value of 5 with the equal sign, and we can see that Eclipse is red underlining this 5, and if we hover over to see what's wrong, it says syntax error, insert semicolon to complete block statements. So, kind of again, we forgot this semicolon, which is a punctuation mark for anything in programming. And so at this point, we have already successfully created an integer called x and set its value equal to 5. So when you make this declaration, there are 3 distinct parts. This is the data type, and there are different ones that you can use, but we're going to use int for now. There is x, and that is just what we're calling it. You could call this y, you could call this z, you could call this w, x, y, z, you could call this my number. It doesn't matter. You just need to refer to it in the future by that name. But when you program, you want to have helpful variable names. So for now, we'll call this x, but it won't be too common to see that in the future, because something like x doesn't usually have meaning to it unless you're referring to like an x or y coordinate, in which case it would be a very nice name. So now that we have that stored, this is part of the computer, and when you run the program, it knows that x is 5, but if I run it, like I just did, nothing happens. You know, we're not telling it to spit anything out to us, but the computer runs, it says x is equal to 5, it knows that x is equal to 5, but it has no way of interacting with us or in telling it that it did anything. So we're going to have it show us that it knows what it's doing. So that with that system out command, instead of printing out a string like hello world, you can just stick in x here. You know, kind of like in math, if you say, well, x is equal to 5, then you know that 2x plus 3 is equal to 13. It's sort of like that, where you can substitute it back in and then do something else with it later. In this case, this system out print function is essentially, you know, plugging into something else to get a result. And in our case, the result is having it print out something. So if you run this, we'll get 5. So the computer has stored x as an int, which is this variable type. It says, okay, x is what I'm going to call this thing from now on. This is how I refer to it. And whenever I see x, I know that I'm actually talking about a 5. And then we tell it to print out whatever x is. And it says, hey, that's x, but I already know what x is. It's 5. And so we print out 5. And notice, as before, where with the hello world, we put it in quotations like this. We do not put the x in quotations, because if we put it in quotations, it would literally print out an x. See, we get an x. And that's not what we want. We want the value of x. And so when you don't have those quotations, it no longer treats it as a literal thing to print out, and you get the value. All right, so let's take it a step further. Let's do some very basic math. So we've already made one called x. Let's make another one called y. Int y equals 10, semicolon, because it's a command. And then we could make a third one, and we could say int z equals x plus y, semicolon. And so when you want to do math, you know, in Java, basically your left-hand side is whatever you're going to be like your result is going to be, and your right-hand side is whatever you're going to be setting to that value. And so this means that z is going to be set to the value of whatever x plus y is, namely 15. And so now if we print out z, we will get a 15 down here, which shows us that it correctly set x and y to 5 and 10 respectively, created a new variable called z, and said that, okay, z is whatever x plus y is, and then said, okay, now we're going to print out whatever z is. And so you've got this chain of action happening here. And in the end, you end up printing out this result of z. And so you could do, you know, something like that. The other thing you could do, you could put x plus y straight in here. Because when it looks at this, you know, when you say a system.out print something, it's going to look at whatever's in the parentheses, and it's going to print whatever's in the parentheses. And if it's not a literal quotation, it'll evaluate whatever in the parentheses. And so it'll say, hey, what's x plus y? 5 plus 10 is 15. And that makes sense because we said that z is equal to x plus y, so it seems pretty logical that whether we use x plus y or z should really make no difference on the effect of how we run things. Just to introduce a couple other variable types, you know, this int can only store an integer, kind of as the name suggests. And in mathematics and programming, a lot of the time, you know, we are not limited to the world of integers. And so in Java, effectively the decimal is called a double. It's sort of a strange name for it. And for now, I'm going to get rid of this for a reason you'll see later. So now we're going to create what's called a double. And we're going to say this double called x is equal to 3.14. Let's do pi. Well, here, I'll even call it pi. This will make more sense. Pi. Double pi. So we're going to create a new variable, and we're going to give it the name of pi. They don't have to be one letter. They can be entire words. This tells us what type it's going to be. So this prepares Java and says, okay, we're going to have this thing named pi, and we need to set aside memory so that we can hold a decimal place. However, Java might do that, which is a little more complicated. And we're going to say, okay, well, now that we've initialized this and know what we're going to do, we can assign it a value. Namely, in this case, the value 3.14. And so now we can go out and we can print pi. And if I run that, I'll get 3.14 down on my console here, which is great. So, let's say you wanted to know what 2 pi was. You could say print out 2 times pi. We've only seen the plus operator so far, but basically, plus, minus, division, and subtraction work just like, they would in any, algebra class. It follows the order of operations. You can put, parentheses around things and say, 3 plus 4 times, the quantity of 3 divided by 9 plus 8, something like that. And it'll follow the order of operations, takes care of parentheses first, then all the multiplication, and it'll add stuff up at the end, just like you've seen in any algebra class. And so if we want to print out 2 pi, so it'll say, okay, I'm going to print something, I'm going to evaluate something, and what I'm evaluating is 2 times whatever the value of pi is. But the value of pi, it'll look back up here and say, well, the value of pi is 3.14. So here we get our 6.28. It's just that simple. And so you could make another double. You could say double, call it y equals 8.957. And if you wanted to print it out semicolon, because it's a command and we need to finish our punctuation so it knows that that's the end of what it needs to do for that particular instruction, and we'll say double z equals pi plus y. And so now if I print out z, I'll get the value of whatever pi plus y is, which is a very kind of awkward thing. And this is actually just a rounding issue, and so it's effectively 12.097. And you can get really deep into how things round with each other and the interactions between stuff like that, but it's something that you can kind of figure out on an as-needed basis, and it's not absolutely essential for understanding the concept of how these things work. Now, one important thing to point out, though, is that if I add 2 doubles, I'm going to need a double to store that, right? If I add this, you can't store that in an int, so if I said something like int z equals pi plus y, it's not going to be happy. And before we read the error, let's just try and figure out why it's not going to be happy. Pi plus y is a double. If you add 2 doubles, you're going to get a double. But we're trying to stick that into a thing that's prepared to store an integer, but it's not ready to do that. It doesn't know how to do that. And so if you highlight over, it says type mismatch cannot convert from double to int. And 2 quick fixes, add cast to int. That effectively means round it to an integer. Don't worry about that for now. And the other suggested fix is change type of z to double. And so that would be the best fix for, in our case right now, to change the type of z to a double like we had it before. And if you click on that, it should actually do that for you, like it just did. So Eclipse even has some auto-fixing built into it, where it can suggest solutions and try and help you out. But just because Eclipse proposes a solution does certainly not mean that it is going to be right or what you want. It's just making its best efforts to guess, but it doesn't understand what you're trying to do ultimately in the grand scheme of your program, so don't trust Eclipse too much. The final type of variable that I'm going to show for now is called a string. And a string is actually, what we saw, hello world. So it's basically a string of characters, a string of letters that make a word. Now with a string, I'll explain this a little more later when we start talking about objects a little more, but a string is not going to be one of these built-in primitive data types that is highlighted in purple, and it'll actually begin with a capital letter, string. So we can say string my word is just some arbitrary name for it, equals, and then since it's a literal string, we put it in quotes here, and then semicolon. So now we could just say print my word, and it'll print hello world. And so what's going on here A string is just a name for what this is, because just think of it as a string of characters that are strung together in a certain order. And so system out print, so we're going to print something out to the console. And what are we going to print? We're going to print my word. Well, what is my word? My word is hello world in quotation marks. And so you can effectively just pretend that that hello world is there instead of the my word, because that's really what variables do. They allow you to cart things around and substitute and talk about something in a general term as opposed to its actual value, which is useful because sometimes things might change. And so it's going to print out whatever my word is. And so that's that. Notice again that it is capitalized and it is not special purple. And we'll have a little more about that later. But that, I believe, was a nice introduction to variables. The three main types we looked at were the int, the double, and the string. This holds an integer. This holds basically a decimal. And this holds a word, in lack of a better word. And I'll put these quotations around it to remember that that's that. And just a quick summary, when you're making a variable, you declare the type, give it a name. It could be a giant word, no spaces though. So it does need to be a single word. And notice here when I had two words, I did not put any spaces in them, and I just capitalized the second letter. That's called camel case when you do lowercase and then an uppercase for any beginning word. So if I were going to have something called my really cool word, I'd do it like this. And it makes it very readable, even though it's just a bunch of letters strung together that don't have any space separation. And so that would do that. So that concludes that, and I hope to see anybody and everybody in the next video, and I hope that was enjoyable.